Welcome to the Deep Dive, the show where we take a stack of dense information and try to distill it into those aha moments you crave. Today, we're plunging into a topic that's, well, absolutely crucial for the future of Web3, but it often kind of goes overlooked. Imagine, if you will, a super powerful, incredibly secure computer. It's got all the processing power, unshakable integrity, but it can only operate on data it already has. Or maybe data that's fed to it manually. It can't, dynamically and trustlessly just grab information from the vast, ever-changing outside world on its own.
That's a really good way to frame it, actually.
Yeah.
What you've just described there is, well, essentially a blockchain. Its main strengths, decentralization, security, immutability, they really stem from its isolation. It operates as this independent, self-contained network.
Exactly. But here's the fundamental challenge, that isolation, while definitely a strength, also seriously limits its real-world uses. I mean, how could a smart contract, say, automatically pay out an insurance claim for a delayed flight if it has absolutely no way to access real-time flight status data? It's just stuck in its own digital bubble, completely blind to what's happening outside.
Precisely. And that's what our sources for this deep dive, places like Cutler University, Forbes, Hackin.io, call the Oracle Problem. Blockchains, by their very nature, can only access data that's already on their own network, like, account balances. For them to interact with our dynamic physical world for basically any meaningful real-world use, they desperately need an external trustworthy link.
And that, for you listening, is where our topic today becomes not just interesting, but really indispensable. This crucial bit of tech is called a blockchain oracle. You can think of them as the essential internet connection, maybe, or the crucial bridge that lets blockchains and smart contracts finally interact with the huge, ever-changing world outside their own networks. So our mission today is to unpack what these oracles are, why they're so fundamentally important for where Web3 is going, the big challenges they face, and how they're being secured and innovated on. We'll cover real-world examples, look at the leading projects, get ready for some hopefully truly insightful moments.
Yeah, we've pulled together quite a stack of sources for this one. Insights from Kanga University, Bake Blog, Hackin.io, KuCoin, Forbes, and even a pretty detailed RFC document on verifiable random functions. Should give you a really comprehensive picture.
Okay, so let's unpack this then. What exactly are blockchain oracles? Because I think some people might mistakenly believe they actually generate the data, but our research clearly says that's, well, not their job.
You've hit on a critical distinction right there. Oracles are not the source of data. They are the intermediaries. That's key. Their fundamental job is to fetch, verify, and then transmit data from external sources, could be websites, databases, even physical sensors, to the blockchain. This is what enables smart contracts to execute based on real-world conditions. Without them, smart contracts are, like you said, essentially blind to anything off-chain. Makes them pretty limited.
Okay, so if a smart contract needs to know, say, the price of Bitcoin in US dollars, it can't just look it up itself. It needs an oracle to go get that data, check its accuracy somehow, and then present it to the blockchain. Is that the oracle problem you mentioned earlier?
Exactly. That's the core of it. Blockchains, by design, have to be deterministic and self-contained. They can only use data that's already stored on their own networks. But for real-world stuff, they critically need external data. Think about a supply chain needing GPS data for tracking goods, or derivative contracts needing live market prices, or maybe an insurance policy needing specific weather data to process a claim. Oracles are the thing that bridges this fundamental gap.
It's becoming really clear how essential these intermediaries are for smart contracts, but it's not like a one-size-fits-all thing, is it? Our research definitely highlights a whole bunch of different oracle types, each seemingly built for specific tasks. Can you walk us through some of these, maybe with some clear examples?
Certainly. Yeah, it helps to categorize them by sort of the direction and nature of the data flow. First up, you have input oracles. These fetch external data to the blockchain. A classic example is price feeds for DeFi applications. They provide that real-time market data needed for automated trading or lending platforms. This is absolutely critical because those DeFi apps need constant, accurate market data to function safely and correctly.
Okay, so bringing the outside world in makes sense. What about sending information out?
Right, that would be output oracles. These send data from the blockchain to external systems. An interesting use case could be, say, triggering a payment in a traditional banking app based on some specific condition being met on the blockchain, like maybe a certain crypto balance being reached or a contract completing.
And what about the big challenge of getting different blockchains to actually talk to each other? We know that's a huge hurdle in Web3.
Yeah, that's where cross-chain oracles become absolutely vital. They facilitate data transfer between different blockchains. They enable interoperability. This is crucial for allowing assets and information to move fluidly across various chains, which is, well, really foundational if we want a more connected Web3 ecosystem.
I've also heard about oracles that do more than just fetch data, like for gaming, where you need real randomness, or maybe other complex calculations.
Uh-huh. Those are compute-enabled oracles. They actually perform complex computations off-chain, so not clogging up the main blockchain, and then deliver the verifiable results back on-chain. And this isn't just about rolling fair dice in a game, though that's part of it. It's about building entirely new, trustless systems where outcomes are demonstrably free from manipulation. Think verifiable randomness for gaming or lotteries to ensure fairness. Projects like Chainlink VRF and API3QRNG are really leading the charge there.
Wow, that's incredibly powerful. And I'm guessing there are ones that deal directly with the physical world too, given all the talk about IoT, right?
Absolutely, those are hardware oracles. These gather data directly from the physical world using sensors and devices. A great example is tracking goods in a supply chain with RFID chips or IoT sensors, relaying real-time conditions like temperature or location directly to the blockchain. Adds a whole new layer of transparency.
Okay, and lastly, what about situations where you need human judgment or, subjective reporting? Not everything can be measured by a sensor.
Good point. For that, we have human oracles. These rely on individuals, often experts, to provide data based on their expertise or observation. Things like reporting election results or verifying specific, nuanced weather conditions where automated data might be insufficient or just unavailable. It adds that layer of human verification when needed.
Okay, so it really sounds like these oracles aren't just some nice-to-have add-on feature. They seem fundamentally indispensable if blockchain is ever going to reach its real-world potential. What's the biggest impact you see them having on just how useful smart contracts can be?
Well, what's truly fascinating, I think, is how they dramatically enhance smart contracts. They make them, as some sources put it, far more versatile by basically giving them eyes and ears on the outside world. Imagine an insurance smart contract just automatically paying out claims for flight delays based on real-time flight data feeds, or for natural disasters verified by, say, weather reports or seismic activity data. That level of automation and trust requires reliable off-chain data, and only oracles can really provide that in a trustworthy way.
And in decentralized finance, DeFi, which is so obsessed with speed and automation, I can imagine real-time accurate data is absolutely non-negotiable there.
Oh, it's beyond crucial. It's the lifeblood. DeFi applications critically depend on real-time price data for everything: automated trading, lending, borrowing, even keeping stablecoins stable. Our research, including insights from places like Forbes, repeatedly points to projects like Chainlink providing reliable price feeds that help secure billions of dollars in the DeFi ecosystem. Without accurate, timely data coming from oracles, DeFi just couldn't function at the scale or reliability it does today. It'd be completely flying blind.
So moving beyond just price feeds, what are some of the new use cases that oracles are unlocking? Because I keep hearing about Web3's potential to revolutionize entire industries, and it sounds more and more like oracles are the key to actually making that happen.
You're absolutely right. They are the linchpin for so much of this. Beyond DeFi, they're enabling really widespread innovation across tons of different sectors. Think about supply chain monitoring. Oracles let you track the authenticity and transport conditions of goods using IoT sensor data, ensuring transparency all the way from, say, farm to table. For gaming, they ensure fairness through verifiable randomness we touched on, that making games provably fair and trustless. And even in sustainability, oracles can incentivize eco-friendly practices by verifying things like reduced energy consumption or recycling efforts, effectively bridging real-world environmental impact with blockchain-based incentives.
And that concept of hybrid smart contracts you mentioned earlier sounds like a real game changer. It suggests not everything has to happen directly on the blockchain itself, which could solve a lot of those scaling and cost issues, right?
It absolutely is a game changer. Hybrid smart contracts use oracles to enable complex, computationally intensive tasks to happen off-chain. This is vital for avoiding blockchain congestion, keeping transaction fees down, but still retaining the security guarantees of the blockchain for the final verified result. This unlocks capabilities that were previously just impossible or impractical on-chain, truly expanding the functionality and practicality of smart contracts for more mainstream uses.
So what does this all mean for the bigger picture then? When we talk about crypto's current market cap hovering around, what, $1 trillion, maybe a bit more, but the global financial system is worth hundreds of trillions. Oracles seem like the essential tech needed to bridge that massive gap.
That's precisely the point. When you connect this to the bigger picture, the scale of potential impact is just immense. Forbes highlighted that the global financial system is worth something like $487 trillion, with over $5.76 trillion transacted annually. Compare that to crypto's roughly $1 trillion market cap. Oracles are the indispensable bridge needed to connect that massive traditional value to real-world blockchain adoption. They allow blockchains to move beyond just being about digital currencies and actually start powering traditional sectors, healthcare, insurance, complex global supply chains. They make blockchain relevant to the everyday economy.
Okay, so we've talked about how oracles solve one big problem getting data in, but our research, particularly from sources like Hackin.io, really highlights that they can introduce another massive problem. The Oracle problem of centralization itself. That sounds like a critical vulnerability, doesn't it?
It immediately raises a really important question, yeah. While oracles solve the problem of getting external data onto the blockchain, if that oracle itself is centralized, well, it creates a single point of failure. This completely undermines the whole point of using a decentralized blockchain in the first place. It's kind of like building an impenetrable decentralized fortress, but then having only one easily compromisable drawbridge as the only way in or out.
I remember seeing an analogy in the sources comparing it to a centralized crypto exchange requires one breach for millions to be affected versus a decentralized network, which would theoretically require millions of individual hacks. That really illustrates the risk perfectly. So the very solution introduces a new critical problem.
Precisely. If you're relying on just one single, potentially compromised oracle to feed data to your smart contract, especially a high-value one, you basically just reintroduce the very vulnerability the blockchain was designed to eliminate. The danger is pretty clear. How can you possibly trust data submitted by a single entity that could be hacked, bribed, or simply make a mistake, especially when potentially billions of dollars are at stake?
Okay, so the solution, logically, must be to decentralize the Oracle itself. This is where decentralized Oracle networks, or DONs, come into play. How do they actually work to solve this critical trust problem?
Right. Decentralized Oracle Networks, DONs, tackle this risk head-on by using multiple independent nodes and often multiple different data sources as well. So instead of relying on just one entity, you have numerous nodes independently collecting and validating the information, often using some kind of consensus mechanism. This multi-layered approach ensures the data is checked, double-checked, and generally agreed upon for accuracy and reliability before it gets recorded on the blockchain. It significantly reduces the risk of manipulation. Chainlink's DONs, for instance, are often highlighted for this combining data from numerous sources and verifying it across many independent nodes. It creates a much more robust network of truth tellers, basically.
And unfortunately, these vulnerabilities aren't just theoretical worries. The sources point to some pretty painful, real-world Oracle attacks where projects lost millions. Can you walk us through one of the more prominent examples just to illustrate the real dangers here?
Yeah, definitely. One really illustrative example, which Hackin.io detailed, is the inverse finance iHack. What happened there was a hacker manipulated the price of the project's token, INV, on a specific decentralized exchange, SushiSwap, which had low liquidity for that pair. They did this by making large swaps. Then, using that artificially inflated price reported by the Oracle, they took out a flash loan and borrowed something like $15.6 million against their valuable collateral.
Wow. So the Oracle was essentially tricked into believing the INV token was worth way more than it actually was, just because it was looking at a single, easily manipulated data point on one exchange.
Exactly. The inverse finance protocol, at that time, was relying on what's called a time-weighted average price, or TWAP, Oracle. But crucially, it pulled data only from that single low-liquidity SushiSwap pair and used a pretty short time sample. This combination of factors, single source, low liquidity, short sample time, made it vulnerable to exactly that kind of manipulation. The lesson learned from this attack, and others like Inverse Finance 2 by NQDAO and Lodestar, is pretty stark. Relying on single, easily manipulable data sources, especially price feeds from low liquidity markets, is a major security flaw. It's precisely what decentralized Oracle networks aim to prevent.
Okay, so given the absolute importance of security, especially when you're talking about things that need to be provably fair, like gaming outcomes or maybe even selecting network validators, that concept of verifiable random functions, VRFs, sounds critical. Can you explain in simpler terms what VRFs are and why they're so important for certain Oracle applications?
Sure. VRFs are basically a cryptographic proof. They prove that a random number was generated fairly and, crucially, that it wasn't tampered with after generation. Think of it like a digital, super secure lottery machine where everyone watching can mathematically verify that the number drawn was truly random, even if they suspect the person running the machine might be biased. One key insight here, highlighted in some of the technical RFC documents we look at, is something called unpredictability under malicious key generation. What that means, essentially, is the system is so robust that even if someone tries to rig the system by creating bad cryptographic keys, the resulting randomness is still unpredictable and fair. This makes VRFs absolutely crucial for things like ensuring fair, unpredictable outcomes in blockchain games, or securely and randomly selecting validators in proof-of-stake networks, where trust in that randomness is absolutely paramount.
That's a much clearer way to think about it, a provably fair lottery machine. Okay, so with all these complex technical needs and major security considerations, who are the leading players actually building out this decentralized Oracle space right now?
Right, so KuCoin and MakeBlog gave us some good overviews here. Chainlink, Link, is pretty widely recognized as the leading decentralized Oracle network. It's known for being robust, having a huge number of partnerships across the space, and supporting a really wide range of data types. Its Link token is used to pay the node operators for fetching and delivering that data reliably. Now, while it's seen as highly secure and has massive adoption, we do see ongoing discussions about maybe its complexity for newcomers and also those sort of perpetual concerns about potential centralization risks among its node operators, even within its decentralized framework.
That's a fair point always, that tension between decentralization and practical usability. So Chainlink is the big one for general data. What about more specialized needs, like, say, the super fast-paced world of finance?
For that specialized financial data, there's Pyth Network, Pyth. It really focuses on high-fidelity financial market data. They boast something like over 380 data feeds, with a strong emphasis on high-frequency updates crucial for finance. The Pyth token is used to incentivize their data providers, often first-party sources like exchanges. Its big strength lies in its partnerships with major financial institutions and delivering that incredibly reliable, high-quality financial data. The flip side, of course, is its niche focus means it's primarily geared towards financial applications.
Okay. And what about flexibility, especially when we're talking about getting data across different blockchains, that interoperability challenge?
That's an area where Band protocol, Band, aims to shine. It focuses on scalability and flexibility, using a delegated proof-of-stake model for its network. It supports cross-chain data sharing and allows users to create customizable Oracle scripts for specific needs. The Band token is used for governance and security staking. Its cross-chain functionality is definitely a plus, makes it quite adaptable. It is perhaps less widely recognized currently compared to giants like Chainlink, which might affect network effects.
And what if an existing traditional company with a standard web API wants to connect directly to a blockchain, maybe without relying on a third-party Oracle network?
Yeah, API 3 offers a really interesting and innovative approach there. They aim to connect traditional web APIs directly to the blockchain. The idea is to empower the actual API providers themselves to run their own Oracle nodes, which cuts out third-party middlemen and potentially reduces points of failure. It emphasizes direct decentralization. Their API 3 token is used for governance within their DAO. This direct API to smart contract interface is a key strength if you want truly first-party decentralized data sources. It's still relatively newer in the market, though.
Interesting approach. And finally, what about a network that's trying to blend different blockchain technologies together for even broader capabilities, really pushing the boundaries of interoperability?
That sounds like Flare Network, FLR. Its goal is secure, scalable data transfer between different blockchains and also the internet. It does this by integrating Ethereum-style smart contracts with the high-throughput Avalanche consensus protocol. Its FLR token is used for governance and also as collateral for assets bridged onto the network. Flare's potential strengths include high scalability, aiming for strong interoperability between various blockchains, even non-smart contract chains like XRP historically, and using that innovative consensus mechanism. However, it's fair to say it's still in active development and rolling out features, so there are naturally some future uncertainties the community is keeping a close eye on.
Okay, this is clearly a really rapidly evolving space. So as the industry matures, what does the future look like for oracles? And what should someone interested in this technology, maybe you listening, look for when evaluating different projects?
Well, the potential applications for oracles are really only set to expand as the whole industry matures. It's just getting started in many ways. We're definitely going to see massive innovation in cross-chain communication. Things like Chainlink's cross-chain interoperability protocol, CCIP, are aiming to set the standards for secure, decentralized data and even value transfer between different blockchains. That's absolutely essential for a truly integrated Web3, not just siloed chains.
And I imagine they'll play a bigger role in things like sustainability too, connecting real-world environmental actions to blockchain-based incentives or tracking.
Absolutely. Oracles are really poised to play a crucial role in sustainability efforts. They can facilitate eco-friendly initiatives by verifying environmental compliance or actions like carbon credits, renewable energy usage, turning environmental promises into verifiable on-chain actions. So for you, the curious learner, when you're looking at or evaluating Oracle projects, whether for potential adoption in a project or even just understanding the space, consider several key things. Look at their core technology. Is it secure, efficient, scalable? How does it handle data verification? What about their adoption and ecosystem? Who are their partners? How big and active is their community? Consider their tokenomics. How does the token work? What are its incentives? And interoperability, do they support multiple blockchains? What are their primary use cases? And do they address any regulatory compliance concerns? And of course, like any project, what's their general financial health and development trajectory?
So what does this all mean for you, the listener, at the end of the day? We've seen how blockchain oracles aren't just some technical add-on. They are truly the fundamental internet connection that unlocks the full potential of blockchains. They transform these systems from isolated digital ledgers into dynamic tools that can actually interact with and respond to the real world. They are, you could say, the essential middleware bridging our digital and physical realities.
They really are foundational. I mean, without oracles, that grand promise of Web3 to integrate seamlessly and trustlessly with the real world remains largely unfulfilled. They really are the eyes and ears of the blockchain.
So I want to leave you with this provocative thought to mull over. Think about the most mundane, everyday interactions you have, maybe tracking where your morning coffee beans came from or validating your identity online for some digital service. What's surprising, maybe currently unimaginable real-world interactions will hybrid smart contracts and advanced decentralized oracles unlock for you personally in the next decade. It points towards a truly connected, functional, and decentralized future, all built on verified real-world data. What application stands out to you as potentially the most impactful?